Hello mathematicians, welcome to another day of doing awesome math with me. We're going to start off our day as we always do with a math warm-up, and we're going to be doing closest estimate, okay? So remember, you don't need a pencil or paper because it's all about doing it in your head, making those complicated numbers easier, friendlier numbers, so it's easier for you to do it in your head. Here is our problem today. 4,578 times 5 equals, remember this means approximately, so about. Your choices are 2,200, 20,000, 23,000. So pause the video for about 30 seconds, give yourself a little time to think, and come back when you're ready. Okay, welcome back. So if you're thinking like me, I always like to round these kind of tricky numbers to landmark, easy, comfy number. So for me, I'm going to think of this as 4,500. Okay, so 4,500. Well, if it was 4,500 and I times it by 5, that's still, I could do it a couple of different ways in my head. 4,500 doubled would be 9,000. 9,000 plus 9,000, so double, right? Would be 18,000, and then I'd add another 4,500, so it'd be 22,500. Now I've added 22 to this number, and that got me to 22,500. So when I'm choosing between 20,000 and 23,000, even when I think of 22,500 and I've added around 25 to each of those numbers, it's still, even with the difference, is going to be closer to 23,000 than 20, right? Because it's 22,000 and some more numbers. And 22 is closer to 23 than 20. Okay? If you rounded this to 5,000 and you did 5,000 times 5, that would also get you to 25,000. And since you know you rounded up, you can also know that your true answer will be less. So it'll probably be closer to 23,000. So 23,000 is the correct answer. Okay, mathematicians, now we're going to get into our algebraic equations today. I first want to review with you some math that you did last week. I think it's Friday. Please, I can't remember. Please turn your page in your book, please turn to page 513. Okay, we're going to go over the final question. Okay, so here we are on page 513, and I completed the chart that I started with you. So here I have it as, 16, 26, and so on, going all the way down. And I wrote my rule for this to be 10 times R, because I noticed that every round I'm adding 10 pennies. So if it's R as my rounds, then 10 times 1 would be 10. Plus my 6, because that's my starting with, and then it equals, that's a P, not a D, a P for total pennies, okay? So then there's this question here, will there ever be exactly 157 pennies? Why or why not try to find the answer without calculating the total for every round up to 157? My answer was no, but I didn't put why, because I wanted to see what you boys and girls think. Well, when I look back at my chart, I already see a pattern happening. Do you notice a pattern happening in the ones place again and again and again? Okay, if you notice that the ones place is always a 6, that's my first clue I'll never land on 157, because 7 is not 6. And if we're always adding 10, we'll probably get to 136, 146, 156, and then we'll pass this number and go to 166. So if I'm always adding 10, and that's in, it has 0 ones, and I'm always on the even number of 6, then I'm never going to land on 157. So that was your first clue, that the ones place is always 6, and that when you add 10, the ones place will never change. Maybe you said, oh, these are all even numbers. Do you see how they're all even numbers? I could split them and there'd be equal amounts.
157 is an odd number because it ends in an odd number. So you look at the last digit to tell you if it's going to be even or odd, and 7 is an odd number. And these are all even. So that's another reason I know that it will never land on 157. So when you get a question like this, like will there ever be, you don't need to make your chart up to there. You can look at the patterns and think about if it's possible to land on a number like that. Okay? All right, we're going to get into today's work now.
Okay, mathematicians, today we're going to do 2 pages together and then you're going to do 2 pages independently. They're very similar. So we're going to practice together and then you're going to do it independently. Please open up your book to page 519. That's right, 519. What you'll notice about your chart is that it has, in the number of rounds, it says 5, 10, 15, and 20. Okay, that's 2 10s. It does not go 1, 2, 3, 4. So you can't just keep adding. You really do need to use the algebraic equation. Remember from last time, the algebraic equation was what I just modeled for you, where you have the number that's added each round times your letter, your unknown number of rounds, the way I just did 10 times R, plus your start with, which in the last one was 6. So you'll have to write that equation for page 519, complete the chart, and then they'll ask some questions about for round 20. If you want to give it a try on your own right now, pause the video and start right away. If you want to do it with me, that's fine too. But if you do it on your own, make sure you carefully check over your work with me once you're done and press play. All right, let's go for it.
Here we go. Here is a penny jar situation. Start with 5, add 6 each round. All right, complete this penny jar situation. What I'm going to do right here is actually write my equation. So I'm starting with 5. So I'm going to go 5 plus, add 6 pennies each round. So I'm going to use my parentheses, 6 times R for rounds, although you can use a different number if you want, or excuse me, letter if you want, equals P. P is for my total number of pennies, okay? So here I go, number of rounds, 5. Well, there's a few ways you can do it. If you wanted to do 6 times 5, if you wanted to go 1, 2, 3, 4, 5, right? 5 of those plus your start with, you can do that. If you want to use multiplication because it's more efficient, that's also fine. So I'm on the 5th round, so it's going to be 6 times 5 equals, well, 6 times 5, that's 30, plus 5, that's right, 35. 35. Here, I can do a couple of things. I can also double my answer. So I can go 35 plus 35. I can double it and get to 70. But what I'm going to do is I'm going to subtract one of my start withs because I know I can't add that 5 twice. So take away 5 equals 65. And what I'm noticing is with 5 more rounds, it's just 30 more. So I can do also 65 plus 30. Because I'm seeing every 5 rounds, it's 30 more. That equals 95. And then this will be 125. Okay, because I'll be 95 plus 30 equals 125. Or I could do it like this. 5 plus 20 times 6 equals, this is 120, this is a 5, and that makes it 125. Be careful that you're writing, I almost wrote a 5 right here, and I had to remember there's 6 each round. So double check when you're doing your math that you're multiplying the correct number. Many students get these 2 numbers switched, and then they get the wrong answer, and they have to redo it. So be very careful that when you're doing your repeated addition or your multiplication, that you are timing the rounds to the correct number. Okay, so now, and then the next part says, how did you find the amount for, sorry, I was gonna sit down, but then you can't see it. How did you find the amount for round 20? So here I have it, so I would explain it. I know every 5 rounds is 30 more, sorry it's messy because I'm holding the iPad too. pennies. So I added 30 plus 95 from round 15. I hope your writing better be better than mine, because none of you are holding an iPad at the same time. Okay. So notice what I did. I wrote an equation. I showed my work. I have my answers. I explained in words what I did. I showed you a couple different ways to do it. Please don't do repeated addition the whole time. I expect you to be doing multiplication. We just showed you how to do multiplication with high numbers. Now it says over here, Jake says the total number of pennies after round 20 is double the number after round 10 because 20 is double 10. Marisol disagrees and says that Jake's method will not work. Do you agree with Jake or with Marisol? Why? Now I want you to understand what he's saying. He's saying if you want to find round 20, all you have to do is double round 10. Do 65 plus 65 to get here. Because 10 plus 10 is 20. So 65 plus 65 is, he says, will be this answer. Marisol says no. What do you think? If you haven't completed this page on your own and you think you have an idea, then go for it and pause this video. If you've already completed it and you're ready to review, then let's go. And if you just want to go with me, that's fine too. So, Jake is wrong because he would be doubling the start with number, which we know is 5. And you only start once. Create a representation for this penny jar situation that shows your ideas about whether doubling works. Okay. A representation. All right, well, here's a jar. And I have 5 pennies, right? That's one quantity. And then I'm going to do each round. So round 1 equals 6. Round 2 equals 6. Round 3 equals 6. I'm just going to show it from 5 to 10. I don't need to do 10 to 20. I just want to show you that doubling doesn't work. Round 4 equals 6. I'm saying how many more get added. Round 5 equals 6. Okay, so this is 5th round. And this makes 30 plus 5 equals 35. Here is my picture. Now, if you wanted to do a chart and not a picture, that's fine too. And I could do round 1 equals 6. 4, 5, 6, 7, 8, 9, 10. Oh, that's a 9. Whoa. And I'm just shortening where my rounds are. And this becomes 60 plus 5. And I'm showing here that you can only have the pennies one time. So that says 10th round. Sorry, my handwriting's so messy today. But the point is that I'm showing with the picture that 5 rounds and 10 rounds, you only have that in starting 5 pennies one time. That's how I proved that. You can prove it with math or whatever other way you want. Your work today is not, this is a review page. It's going to be what says homework. And it's 2 pages, but that's because these charts take up so much space. So basically what's going to happen is you're going to have 2 penny jar situations. And you actually have to figure out what the equation is. So I can figure it out because I know how much I start with. and I can see how much was added. So if I can see how much was added, I know how much is added each round, right? Okay, so if you're ready to go, just go for it. If you want more help, watch. I'm starting with 7, so I'm going to put 7 right here. And 11 take away 7 is 4, right? So 4 plus 7 is 11. So I know that each round they're adding 4. Because see, I can see it right here. 23 plus 4, that makes 27. So they must be adding 4 each round. Now I have my equation. So I can add 4 if I wanted to. I can also do the jump with after 20 rounds by using my equation. So do what makes sense to you. Here's 10 rounds too. But don't double. Remember, we just learned the problem of doubling. Same deal over here, except you can see that after round 1, we don't know, but after 2 rounds, there's 16. So after 2 rounds, 10 have been added. So then how much gets added each round? If 2 rounds, you have 10. Then after 1 round, you have to take 10 and cut it in half. Okay? So if that's confusing to you, so remember, if you have 2 rounds plus something, it equals 16. Plus something, it equals 26. And you're adding the same amount. I hope you can figure out how much is added each round. It's 5. Okay, so you're going to do page 524 and 523 on your own.
Mathematicians, I was so happy to see how many more students got correct answers and showed their work on their Friday's assignment because they watched the video. I hope you're doing the same thing today, because I know that when I make this video, I'm thinking about you and all the help I can give you, and I'm seeing your brains grow even from a distance. Miss Carrot and I wish we were there with you, but since this is the best we can do, make sure to keep watching these videos all the way to the end, okay? So do those 2 pages, check your work and any feedback you get, and have a beautiful day. Take care.